Right, sup guys, today we're gonna learn about a new type of faction. So, of course, the name of this faction, I don't really like to say it in a normal way, so I'll just call it a extra faction. So, okay, it's not actually called an extra faction, I just like to call it because I don't really like to remember real names, right? So we have our normal faction, all right? It's a numerator, denominator. That's a normal faction. But an extra faction is like this. A normal digit, a numerator, and a denominator, all right? So it's three parts. And usually, this type of factor is usually seen in dividing problems. Like, for example, problems this. So, you are wondering, how do you calculate it? All right? Because it's an extra digit. Well, here's the thing. Factor. Let's say you have a 5 on 5, right? That equals 1 because the factor has reached an equal amount to 1. So, 4 and 5, all right, it will equals 20. But remember, it's a numerator as well. So you have to add it with the current numerator, giving you, removing this digit, and giving you a normal factor of 21 on 5. Divide, you have to change it into a multiplication because, of course, multiplying factors, you just change it into, dividing factors, you change it to multiplication, but you flip the divider factor. And then you get, this. And because there's two fives, you can just cut them away. And you get 21 on 2. Because either way, you can divide them by 5 and you'll get the same answer. It just makes sense to just do that, alright? And now we're gonna move into some other problems so you get the grip of it, right? So also, of course, there's multiplication problem with it too. So let's say okay, but real quick note is that the x that's used for multiplication, guess what? You don't get to use it anymore now. Because now in this type of math, you have to change it into a dot. Because who the hell is not gonna waste their time on just writing a whole an X, and sometimes they'll even have a dot or an X. They just write it like this. Right, in like parentheses. So even though there's not an X or a dot, you can easily tell this is a multiplication problem. Actually, you don't, because two numbers in parentheses right next to each other, I'm pretty sure you will not be able to tell that it's a multiplication, but that's why I taught you there, alright? So, let's try and do this problem. Hold 5 on 1 on 12, change it into a easy 11 on 2. 2 on 3, you get 6, add a 1, you get 7, 3. And then you multiply it, but first, you only do this when you're calculating. Don't actually write it onto, your paper or your exam or anything. Just write it when you're calculating. So just remove this. Put the little dot if you have to. You need to. And then you get your answer of 77 on 6. But of course, the number is an extra factor. So of course, you can obviously change this. So, alright, you'll get a, you don't have to change it. You get a, you got 12 on 6, because, 6 times 12 is 76 plus the 1. You get that answer. And now we're going to move on to one thing left, alright? The extra factors have one singular issue, one singular rule, is that if, one is like this, if they both have the same denominator, you could actually add in the numbers, or you can change it to a factor. So, for example, you have this, and then erase the 2, and you put it to the side, which will give you a. Hold up. Which will give you an extra factor of 32.2, and then from then on, you just calculate. It's not that hard, alright? And plus, it works a little differently than normal factors as well. So usually, when normal factors add, you have to have an equal denominator. And well, here it still does. Okay, I don't know why I said that. That was kind of pointless. So the thing is, its multiplication process is longer, which you just saw because I demonstrated already. So yeah, that was the lesson. Extra factors, not exactly as easy to grip as normal factors, but hey, it's not too hard, right? Hopefully it isn't for you.